like Tom, I also do not have answers. I do, however, have some suggestions and a story, an example of what works for us. So as been said, this is Network Infrastructure, Build, Test, Deploy, Repeat. I'm your host, Joe Clarke. This is the abstract. I'm not going to bore you reading it. You can read it in the agenda, but I do want to call your attention to the first sentence, the question. Do you feel comfortable making a network change in the middle of the workday into production? Some heads nodding. There are some people out there who have adopted this, who have said, you know what, we're going to do this. We have the confidence, we have the technology, we have the rigor, and we have the discipline. And what I'm going to take you through in this brief 30 or so minutes is our journey, how we approach this, and some of the things that we learned from it. We're going to start out with this idea of what is this concept of net DevOps, not too scary. There will be a tooling bit of discussion there, how we're going to build this confidence, what we're going to use to build it, and I'm going to show you a practical example and give you some code where you can play with it yourself. I do tend to like the sound of my own voice, so if there are questions, just let me know. There's no dedicated question spot, but if you have questions, I'm happy to answer them. Now, this is going to be hard stuff, and it's not necessarily hard like rocket science. It's not something like, wow, I can't get my head wrapped around this. It's hard because it requires a lot of effort. It requires a lot of discipline. It requires rigor. And there isn't really a one-size-fits-all or a here-it-is solution. Like, Tom, I don't have the answers. I have suggestions. So the hard part is how do we make the suggestions work for us? What is practical here? What could we take back and incorporate into our own environments? What could we do better? How could we change things? And how do we adapt to how the network has changed? That in and of itself is hard. Because if you remember, some of you might, the Network of Yore, it was fairly straightforward, right? They had some routers, maybe some switches. Switches were new fandangled things when I joined Cisco, and maybe some servers, things that connected and provided services. And as network people at the time, we didn't really care about the servers. That was someone else's problem. We cared about the network. But now look at the network. This is what we're dealing with. Yes, we still have the routers and the switches, but now we have virtual network elements, NFV, and those run on servers, and therefore we kind of have to care about the servers. We care about those virtual network elements and the virtual machines or the containers they're running in. The services that drive the network have become more complex too. We've got our usual, our DNS and maybe our DHCP, but we also have load balancers. We have firewalls, stateful firewalls. We have intrusion prevention systems. And that's great, that's all in our data center. But then when we look at someone else's computer, i.e. the cloud, we've got the same type of thing over there, and we need to connect it all and make everything secure. And how are we deploying changes into that environment? How do we ensure that what we're putting out there, what we're deploying, actually works and is effective and delivers the value or delivers whatever outcome we want? So that's where this idea of net DevOps comes in. And what it is really just a portmanteau of this idea of network operations and infrastructure meeting this more philosophical concept of DevOps. The philosophy of DevOps is here. You've got the culture, the automation, it's lean, you have measurements and collaboration and sharing. We're going to focus mainly on the automation piece today. But I want to call your attention to the culture piece, because that's something that really bit us when we started doing this. It's trying to get people out of the mindset of doing things manually. It's so easy to SSH over to that device and just make a quick change. It's the mindset that we need to be in, that we're following the process. That way we can ensure that we're able to deploy successfully without an outage in the middle of the workday. But in terms of the automation, since we're time limited, we're going to look at this idea of employing continuous integration and continuous deployment pipelines. We put something in the beginning, it runs through some automation, and we get an outcome at the end. And that outcome is deploying after testing into production. So we're going to automate all of that testing as well through this pipeline. And we're not just going to automate the testing of the state, or the testing of the configuration. Yeah, we want the configuration to succeed. And if it fails, that's an obvious failure. But we also want to look at that state, at that operational data. Some of this is referred to as infrastructure as code. We no longer look at the configuration of the network as just these commands that some vendor came up with. Instead, we look at a more abstracted as code type of approach, and we use some of those same tools in order to drive this automation, in order to drive this pipeline. Graphically, this looks like what should hopefully be a virtuous cycle. And without that cultural element, this can turn into something that just adds process. But if the culture is there, if people are bought in, if they understand what's going on, then the way this looks is you hang around the design part first, so a little down there in the yellow. In the design, and we just did this recently, we were creating a model for our firewalls. We weren't automating or abstracting all of the configuration on the firewall, just what we needed for our particular service. So we designed, like, this is what it's going to look like. This is how we're going to add, these are the access lists, these are the policies we want. So we designed that. And we say, is this right? Did we do it right? Well, let's deploy it in this pipeline I'll show you. It'll run through the tests. It'll deploy it into a safe test network, a virtual test network, run those operational tests, confirm that it's doing what we want, and then we can deploy that into production and begin to operate on that. And that's the cycle. Our stack, the way this looks like, is we have everything governed by a source of truth. Not necessarily a single source of truth, but a source of truth. And I know Brandon is going to be talking a little bit later today. Source of truth is going to come up. I'm not going to focus so much on that today because we've got that middle part where you don't have the dashed lines. That's what we're going to look at. We're going to look at employing a source code control system to act as our infrastructure as code engine. And that can be considered another source of truth, and that's why I didn't use the word single up there. Below that, this is the piece that's going to be doing that automation. This is the piece that's going to be driving the bits of the pipeline, moving things along the pipeline. And then we have the network piece that goes and deploys out into the network, deploys our configuration, translates our abstraction into network configuration, and then we want to run those tests and automate and verify that everything's good. And when it is, we cannot forget. We now have, okay, we've got this thing in production. We now have to let our monitoring system know, hey, we've got this new service, or we've got this new outcome that we need to look at. We need to make sure it's secure and that we've locked it down and we've let our policy system, or if we have any secrets, we've updated our secret store. If we have anything that we have to report out of that, logs or any results, we want to make sure we save those as well. So that's the stack. But as I mentioned earlier, there isn't a one-size-fits-all. There isn't an answer for this. You'll find you're probably already using some of these pieces. There are rules, or there are guidelines, I should say, that can help you choose or figure out if this tool is right at each one of these layers. So for example, even though we're not going to get too deep into the source of truth, you want something that's going to kind of drive the rest of this, that's going to hold your relationships between network elements, like how things are interconnected. What makes up these network elements? What is my IP addressing? And I know Alex is going to talk about IPv6. What is my IPv6 addressing? We have to have all of that well contained so that we can cascade that down, that everything flows very nicely and it's interrelated. And that goes back to that culture element. We have to teach our people, our operators, our engineers to follow the methodologies, to make sure they're updating that source of truth so that we get clear pictures and clear results as we move down the stack. So as we look at our next kind of source of truth, your source code or revision control system, you want something that obviously maintains history, that you can go back, and if you have to revert to a previous state, it's very easy to do so. You also want to know, like, hey, why did this thing change? I want the comments. I want the reasoning there. And I want to be able to do it collaboratively. It's not always just one person making this change. They might need input from someone else. You might be taking two different approaches to a solution, and then you want to look at them or test them independently and see which one works best. So we need that parallelism. In terms of the continuous integration and our continuous deployment, we need this engine to be able to obviously operate and work automatically, to drive the different elements of the pipeline, to drive the deployment, and to drive the automated tests. And ideally, it should allow you to review and say, okay, this test passed, are we sure we now want to move it into the production stage? Maybe that can happen automatically, but it's always good to have another pair of eyes, to have some human reviewing right before it merges into your production state. From a network automation standpoint and a validation, verification, and simulation standpoint, from an automation, you want to make sure that you can take that abstracted config that can support multiple different vendors, multiple different types of network elements or network services, and translate that into something that is real. Those services, those network elements, network functions that they understand. It should support multiple environments. It shouldn't need you to define things that look like a specific CLI or a specific API. It should be able to abstract that. And in a simulation environment, you want something that's going to be as close to your production network as possible, so that when you're testing in that safe environment, you know, I've got fairly good confidence that when I deploy this, it's going to work in production because I've tested it in this simulated environment. You want to be able to make sure that you can analyze traffic, that you can inject, to really validate that operationally your changes are going to do what you want. And then from a verification standpoint, test the state. Don't just assume that because this is configured correctly, this IP address looks right, that state is going to actually do, that operationally it's going to do what you want. And like I said, I'm not going to get too deep into these, but make sure you're closing that loop. Make sure you're pushing, once that change goes into production, make sure you're updating these other systems so that you have the complete and an accurate picture of what your network is doing. All of these throughout the stack, you want things that are API driven, that are programmable. We're talking automation. You want to make sure that you are able to automate to this as well, that you can program at all of these levels and drive this with as minimal human interaction as possible. So with that, let me show you a practical example. This is what we're doing. May not be the right thing for everybody. This is what has worked for us. Our network. What device is that? No, this just gives you an idea of the scope. This is our data center. This data center in Cisco will run, we're building it out now, will run all of our learning operations. So everything we do for customers in terms of labs, in terms of exam-based courses, things of that nature. It consists of data center switches, it consists of routers, we have physical and virtual firewalls, we have virtualization elements in here, and because of that we have virtual machines, and we have to manage all the way down to that in an automated fashion. So when we deploy, say, a new lab, a new course, we have to be able to automate all the policy changes to allow students to come in and do all of this. So what we have done, taking our stack again, we've chosen to use Git and GitLab in particular for our source code, and for GitLab CI for the continuous integration piece. That's going to drive the pipeline. We've created a YAML-based abstraction for config, and we're using Ansible to push that into our network devices. From a simulation standpoint, we use Cisco Modeling Labs, which allows us to run full virtual machine instances of the network operating systems we need. And we use PyATS as a kind of a pseudo open source testing framework to be able to drive our automated tests. Taking the example a little bit, distilling it a little bit down, I've created a sample VLAN Fabric, just an abstracted version of the configuration, a small test network, and I put all the code there. I'm going to run you through an example of this working, but you can see this is a scaled down example of what we're actually building and what we're actually using. You have the abstracted YAML VLAN config over there. CML will allow you to create a testing network that is a copy of the production network. So when we deploy that VLAN, when we make changes to the VLAN fabric and we deploy it, it's deployed first into that testing network. The tests are run, and if those tests are successful, we can push to production. And in the canned example I've created in GitHub, the production network is also virtualized. So you can see the whole end-to-end working as you merge from your branch for development, see the tests run, and you can merge that over into the main branch and have it quote-unquote deployed in production. All of that deployment is done using Ansible. So Ansible deploys, there's a playbook there you can look at, deploys the configuration at the router layer, at the switch layer, just putting in the configuration, taking that abstraction, making it real. And then the testing is all done with PyATS. So PyATS is looking at things like the configuration, saying, is that IP address actually on that interface? Great. Not stopping there, though. Then it looks and says, okay, from a fabric standpoint, what does spanning tree look like? Are the ports that I expect to be forwarding? Is the spanning tree route what I expect to be the spanning tree route? Can I get end-to-end connectivity from a host in my fabric out to the internet? Does all of that operationally work? And as I make changes to this, are those tests continue to run, are those tests still effective? And with something like PyATS, you can fold in additional tests to make sure that what you want, you're achieving. So maybe, for example, you notice one day in production, this is some weird bug that you found, and you want to make sure that you're testing for that kind of situation in the future. You can fold in another test. It's just another Python script, and it can start to run automatically now. So let's see it work. So here's our demo. Here's our VLAN Fabric, that abstracted version of the config. This is what you're going to get if you decide to clone this repository. We have our pipeline. A wise man once said CI/CD is nothing more than just bash scripts tied together with YAML files, and that's essentially what this is. This is what's going to be, what's going to drive our deployment. So we've got some bugs. We're going to create a branch to fix these bugs. So we'll create a branch off of main to fix our fabric, and we'll fix a few of the typos we had in the file. We'll change the IP subnet. It was mistyped. We'll change the VLAN, and then we'll commit this back into our revision control system, and we're giving it a message, a commit message. Again, culturally, we always want to make sure our commit messages are as accurate as they can be. Fixed fabric bugs probably could have been a little bit better, but this is a demo. I put it to you to make better commit messages than I did here. So as soon as we push this up, if we bring up GitLab and we look at the pipelines, we see a new pipeline has been created for fixing the bugs, and it's got a few steps. It's first going to configure our simulated test environment, then it's going to test the fabric, the spanning tree, then it's going to test the end-to-end connectivity, make sure that we actually can achieve the end result goal. We're going to go in movie time now, much faster as it deploys the container that's going to have all of the necessary dependencies. As soon as it's done installing all the Python dependencies, you're going to see in the CML screen, it programmatically brings in the topology and starts it up, and then the Ansible playbook kicks off to start deploying the configuration, so translating the abstracted config. The next step is to test the fabric, and it waits for all of the spanning tree to converge. Then it'll kick off this test step. This is where PyATS comes in. PyATS is going to look at the configuration, obviously, but also at the state, at show commands. Is the spanning tree operationally functioning as we intend, connects to all of the devices, gathers all of that information, and then we can look at the output, and it's looking at the output. Does it see all the ports the way they are, forwarding? Does it see the route where it needs to be? Yes, it does. Then the job succeeds. And then it kicks off to the final test, that end-to-end connectivity. Will that end-to-end connectivity be successful, or are we still missing something? And if it is successful, at this point, we've completed our pipeline on our branch. It's not in production yet because we created a branch to do this development. We want to make sure that all of these tests work in our simulated environment, in that topology over there. When we see that we have that end-to-end connectivity and all our tests now pass, now we can choose to merge this over into our main branch, which we'll deploy to production. When we're done, we can also have a thread, a job that goes out and cleans up, programmatically cleans up our topology as if we were never there in our Cisco modeling labs, in our test environment, thus leaving us with a clean slate in order to do our next test, in order to send out our next potential configuration change. For those of you who can't wait for the movie, I've listed a few resources here for obviously the code that is essentially that example we just walked through, and docs on Ansible, Cisco Modeling Labs, GitLab, and PyATS, which are all used here. And all of the code for the tests, the PyATS scripts, the Ansible playbook, all of that is in that simplified example GitHub repository. So again, not a solution, not an answer, but this is what we're doing, a suggestion. If you practice building, testing, or most importantly testing, then you can deploy into production in the workday and have that confidence that the network is going to do what you expect. And you're always going to have that agility to be able to move forward as fast as you need. I went kind of fast. I'll pause. I think I've got a few minutes for questions if there are any. Yeah, I think, head up to the mic, please.
First of all, really great presentation.
Thanks.
Well spoken too. That's great. On that abstracted config,
yeah.
Did you guys develop your own abstraction and then translations for that, or is there a library that you're using off the shelf? Is it just Ansible? Or?
We developed our own model, so we decided these are the aspects. We didn't model the entire configuration, like where Cisco, we used somewhat a bit of Cisco stuff. We didn't model all of the Cisco config, just what we needed for our services. And within the Ansible playbook, and you'll see how it works, we just have Ansible code, if you will, that takes the YAML variables, the properties, and puts them in. So we develop the translation layer there. We don't have any additional libraries, though I know Neela will be talking about other frameworks like Nornir and Napalm, but we just did it this way. We focused most of our effort on just keeping the configs as simple as possible so that we didn't have to bring in a lot of additional dependencies.
So, I mean, all the network automations revolving around the programmability of the devices.
Mm-hmm.
So, I have a question: what is your suggestion for operators still operating really legacy network, which does not have that kind of programmability, and we still have to do CLI scripting?
So that's exactly why we chose Ansible, because it presented us a lowest common denominator. What's actually happening there, even though most of our devices have some level of like netconf or restconf at this point, it's using a CLI. So Ansible provided that layer of abstraction so that we can think not really about how the config is being put on the devices. We're focusing more on what is our abstraction, what are the tests we want to run. And you'll also see in PyATS there's additional abstraction that it can do to take the CLI, the legacy human-based CLI, turn it into JSON, the things that are modeled that are more machine consumable. But we absolutely, exactly what you said, we have to think least common denominator, and there are other tools out there that can do it. Ansible was fairly effective for us. It's got a lot of support across different vendors, across like plugging into cloud, public cloud operators as well.
Thank you.
Okay, thanks for the presentation, it's awesome. Question for you around abstraction. How abstract are you going? Are you going like, abstract for vendor language where you're still specifying specific interfaces, specific VLAN numbers, things of that sort? Or are you doing a higher level abstraction where you're like, I need a service, give me the next VLAN, give me the IPs, I don't care, that kind of stuff.
That's a little, if the canned example doesn't have it, but that source of truth is where that comes in. So what we're actually doing, and we use Netbox, just as a disclaimer there, what we're doing is we're actually going to Netbox and pre-building the topology based on the interconnections in Netbox. So if we know that this interface on this device is connected, so we build our topology, our inventory from that, from an Ansible standpoint. And we can do things like give me the next IP address if we need to, or if we pre-reserve an IP address, we can pull that out. Same thing with VLANs. But the canned example is more static in that nature, but we're using, that's where the source of truth comes in that particular case. Well, thank you very much. It's tough being the first speaker, but I look forward to a great rest of CHI-NOG 10. Thanks.